Well, hello there, everyone. I assume that you guys have solved the guest birthday issue, but if you have not, then let's do it one last little time here. So I'm just going to run the project. So, is my birthday in this set? I'm going to say my birthday is the 26th. So no, my birthday is not in this set. Is my birthday in this set? Yes, it is. Is my birthday in this set? No, it is not. Is my birthday in this set? Yes, it is. And then finally, is my birthday in this set? Yes, it is. My birthday is 26. It got it correct. So, if you haven't figured out what this is doing, one thing you may want to notice is the ones and zeros that I've input. If you look carefully at that and put it in reverse order, therefore, if we move from bottom to top, that will give us reverse order. We will get 11010. This is binary. If you were to convert that into decimal, exactly, we'll do it right now. If I move this to be the programmer calculator and I put in binary 11010, we'll see that in decimal, it's 26. So our program here runs off of decimal, or binary, actually. Binary is what it runs off of, but it gives us decimal in the end. So how do we end up doing this? And how does this actually work mathematically? Well, the thing is if you take a look at set 1, and we take a real close look at that set, I'll actually zoom in a bit. Can I zoom in? I don't think I could zoom in. Yeah, I don't think I could zoom in. But if we take a look at this set, actually I can just close this. And then I can, see with that, I can zoom in. So as we see with this new set, or the set 1 that we have, we see that every number is odd. Well, why is that? Well, the last digit in binary is a 1 or 0, and that basically means, is my number even or odd? It turns it on. If it's odd, it'll be 1. If it's not odd, it'll be 0. So I have to give you all the birthday numbers in this set that will be odd for it to be an odd number. Therefore, I can easily cut out half the numbers if I already know that your birthday is in this set. Now, I'm still going to ask you the birthdays for everything else, but for it to be odd, it will be in this set, and this will be turned on. Then the next set contains the numbers that will require this number to be on. So if your birthday is on the 2nd, then you have 10. If your birthday is on the 3rd, then the binary will be 11. Binary is on the 6th, then it'll be 110. So forth and so on. So if this bit needs to be on, then we know. Now there's nothing in the set that can be greater than that can be equal to 1, because the last binary digit indicates 1. If we look at the next set, this is the binary digit for 4 and above. So therefore, anything less than 4 cannot be in this set. Same thing with the next one on. This is now the binary number for 8. Nothing less than 8 can be in this set. And for the last one, this is binary number for 16, so nothing can be less than this. Nothing can be less than 16 in this set. Otherwise, it would make no sense. So if we go to take a look at the code, what I'm doing is I set up all my sets. They're all in a string, and this break character is a new line character. So it just easily creates a new line. I could have this all stacked on top of one another, but I did it this way. I prefer expanding things than top line. That's just my preference in code. Some production environments, or if you work in production, some of them require that you stack And by stacking, I just mean just having this like there and just moving it to its like ordered location like that. That's stacking. It can be helpful. I'm not a big fan of it, but that's just me. And then I create the scanner so we can ask the user for inputs. This is just a typical thing that we have to do if we want to ask users for inputs. Then I'm saying, is your birthday in set 1? I print set 1 and enter 0 or no for yes, or 0 for no, 1 for yes. And I've created a day summation on line 18. And then what I'm doing is I check their answer based off what integer they give me, which is either 0 or 1. And I check if it's equal to 1, then I will add 1 to the day. This is the binary digit for the first place location of binary, and then you can only add 1 to it. Then I do it again for set 2. This now gives us 0 or 2 to add into it. So if we have it on, we'll add 2. If we have it off, we don't add anything. We could add 0, but there's no need to. Anything plus 0 is itself. Do it for set 3, and since the third binary digit number is 4, we add 4 to the day. If it's in set 4, then we know the fourth binary digit is 8, and if it's in set 5, then we know the fifth binary digit is 16. So that's just what we have to do, and that's exactly what we did in this situation. Now, how do you know that all these are in, like, what numbers are in each set? That's just something you have to do manually. You can binary convert it all into, like, each number into their binary conversions and just group them up together going, oh, this is in this set, this is in that set, and stuff like that. That's probably the most tedious part of this. Maybe you're just given it and that's an easy situation, but I wasn't just given this. I had to convert, and it's not fun. But that's how this actually works. And then I just grouped it up by sets based off of is that binary bit on or off? And that was pretty easy. So this is actually how the solution of this code should be. It should look something along these lines. It doesn't need to be exactly this. Everyone has their own different coding style, coding preferences, but it needs to have the same gist of this. If you found another way to do this without using binary, please let me know. Comment below and I'll reach out to you and see how you did it. I will see you guys next time.